Yes, good morning, everyone. My name is Einar Næss Jensen. I work at a university in Trondheim, NTNU. I'm currently a team leader for the local HPC team. And I also, in this context, I'm the team leader for the NRIS Infrastructure. I have been working with the HPC for the last 14 years. And before that, I have been doing a ton of IT support for scientists in regular IT operations. My background is media science, journalism, informatics, history. So there's that. Yes, I have a bad habit of talking too fast, but I will try to do this slower than I regularly do, but we'll see. So a broad overview of our hardware. So that's what I'm going to talk about. And the data centers that we do, where we currently operate NRIS hardware. It is in Lefdal Mines, where we currently have the new NIRD facility. And the upcoming A2 project will also be placed in the Lefdal Mines. We have the Fram HPC system in Tromsø. We also have the old NIRD infrastructure is still in Tromsø. And in Trondheim, we do have the Saga HPC system. And we have the Betsy HPC system. And we have the other part of the old NIRD storage system. To get a view on how a network is constructed in our facilities, it's well, this is an attempt at drawing a picture of how things are connected. I guess that this picture comes out a little bit unclear in your screens, but the main point here is that on the network side, to get all our users, that means you people, connected, there is a lot of redundancy involved. You can see that all our network connections are cross-connected, so that if we lose one link somewhere from our system up to your connection, you will still be able to connect somewhere, and that goes also for our login services on our systems. If we lose one login system, we do have spare login systems on every system. So the network in Trondheim is similar to that in Tromsø. We do have additional network equipment because we do have 2 HPC systems, but the design is more or less the same. And you can see the network design for the Lefdal Mines is also more or less the same. And it is because we want this redundancy. So this is a picture of the old NIRD and the NIRD toolkit. This almost doesn't exist any longer because we have this new, very good NIRD platform in the Lefdal Mines. But this is what it sort of looked like. So the new system in Lefdal, it is very much simplified compared to the previous setup we had. It will hopefully also give us the opportunity to couple the needed storage more tightly to the upcoming A2 system. There is also one additional thing with the new needed storage, and that is that we have got a storage with the S3 or object storage access. And we hope that this will make it easier to access data via APIs. In total, there is approximately 30 petabytes of storage in the new storage system in Lefdal Mines, with the potential to grow a lot. We do have the needed toolkit also. Currently, that is a Kubernetes cluster with 8 nodes, and 3 master nodes and 5 worker nodes with the GPUs. And this one is directly attached to the needed storage with the GPFS. This enables us to run containers. Our current HPC systems, we have from it was bought and put into production in late 2017, and we have a picture here. And Saga was coming in 2019, and we have Betsy in 2020. So all these 3 machines I wouldn't say that they are getting old, well, except for From is getting a little bit old, but it is absolutely about time to acquire a new one, and we are in the process to do that. For the more specific hardware information for the different systems, the From system is a Lenovo NextScale system. It has 32,000 cores and 1,000 nodes approximately. The CPU is Intel, and I see that now that the slide says that we have a huge mem on the From system. Those nodes has been moved to Saga actually. The theoretical, the max floating point performance we have on From is 1.1 petaflops, and we have almost 80 terabytes of memory, and we have the disk capacity is 2.5 petabytes. And if anyone was trying to use From yesterday, you noticed that our file system crashed. That was not our fault. It was because of some UPS work in Tromsø. But we do apologize, of course, for this interrupt in service. We still have some problems with the From file system, but which we will have to look into. later this week. So the network from is InfiniBand, and that is the same actually as with the other systems. All our systems have InfiniBand. This one has EDR InfiniBand, which is 100 gigabit, and the operating system is CentOS 7.9. File system is Lustre. When it comes to Saga, it is an HPE Apollo system, and we have 10,000 cores. And the number of nodes are substantially fewer than in From. We have 220 nodes. And I'm starting to wonder if this number is correct, if this is including or not including the new expansion, actually. Well, that being so, we do have 8 GPU nodes, and there are 4 GPUs in every node, so a total of 32 GPUs. There is an ongoing process of expanding the GPU partition on Saga, and we are expecting some news regarding that in the upcoming 2 or 3 weeks. The CPU is Intel, and the GPUs are currently it is NVIDIA P100 cards, but as mentioned, that this might change in the near future. Max floating point performance is 0.65 petaflops, and we have a total memory of 75 terabytes. The total disk capacity is 6 petabytes. And we do on Saga, we do also have NVMe local scratch disk. And if you have need for a local scratch, Saga is definitely the machine to do work on. The network on Saga is FDR InfiniBand. So it's the InfiniBand is has lower bandwidth than on From. The reason for this is that what we need on Saga is low latency and not necessarily high bandwidth. The operating system is, as of today, Rocky 9, and that was we upgraded the operating system 2 weeks ago. It was a huge task, and for now it turns it seems like it has been a success, and we will continue with this upgrade process, and we will upgrade both From and Betsy in the future. The file system on Saga is BGFS, which is BGFS is designed to handle lots of small files. When it comes to Betsy, this is a very it is not built from off-the-shelf components. It is based on Bull-Secana XH2000 cabinets, and it has 170,000 cores and 1,300 nodes. The CPU type is AMD EPYC Rome, and we have a performance of 6.2 petaflops. Total memory is 336 terabytes, and the total disk capacity is 6.5 petabytes. And if you have been using Betsy for the last year, so the last 12 to 18 months, you might have noticed that we have struggled really with the disk capacity in Betsy. But 2 weeks ago, this was more or less resolved, as we have moved most of the NID projects. We have moved them to Lefdal NID facility, and we have also deleted some old backups that we had laying around. So both the capacity and the performance of the file system on Betsy is a lot better today than what it was 2 weeks ago. The network on Betsy is HDR and HDR 100. So it means it's a combination of 100 and 200 gigabits InfiniBand. The operating system is based on a Red Hat 7.x version, but it is a specific bull Sakana tailored Red Hat version. But for all practical matters, it is Red Hat. The file system is Lustre, the same as on Fram. When it comes to storage systems, so this is what it looks like on the HPC systems. I couldn't find. I've been trying to find a good picture of the needed storage system, but I couldn't find none. But then next time I will have some pictures of the needed storage systems. But this is what the storage systems on the HPC systems look like physically. And something that might be worth noticing is that while the capacity goes up, the physical size stays the same. And I could have thrown in a picture of the storage system from the NTNU HPC system from 10 years ago. In physical size, it would have been the same size as the Fram 2.5 petabyte, but the storage size would have been 600 terabytes. So that is that. There you have the Moore's law, I think. On our different HPC systems, we have different network topologies. And on both Fram and Saga, we have a FAT3 topology. And we have different levels. On Fram, we have 3 levels with a factor of 18 to 16 to 4. On Saga, we have 2 levels with a factor of 28 to 6. On Betsy, we have this sort of weird network topology called Dragonfly, and it is, if you use the same convention for the Saga and Fram, we have 5 islands with 3 levels of network. And the picture on the right here, on the bottom, that is an actual rendering of the network on Betsy. This is what it looks like from a network's perspective. When it comes to choosing the right machine, and you might not yourself get to choose the right machine. It might be that other people will choose the right machine for you, but this is more or less the criteria we have. On Saga, we prefer to run single core jobs up to a single node job. We emphasize high IOPS on scratch shared file system, and we have the availability of extreme high IOPS on node local scratch. On Fram, we emphasize single node to intermediate large jobs, and we have a high bandwidth scratch file system. On Betsy, we try to run, or we prefer multi-node to very large jobs. And we have a very high bandwidth interconnect and intermediate high metadata scratch file system. There's one thing I failed to mention, I think, when it comes to HPC system. On the Betsy machine, we do also have GPUs. We do have 4 nodes with 4 800 GPUs in each node. So that is something to be aware of. On all our machines, we do have the ability to set up virtual machines for specific projects. If you have particular needs, we can do this on Saga and Betsy. It's not something that we do a lot of, but there is a possibility there if you have some specific needs. Currently, Sigma 2 and NRIS, we are in the process of getting a new machine. So there's no name yet. So the working name is A2. And we don't know yet what this machine will be like, but we foresee that it will be we do know that it will be both CPUs and GPUs in this machine. We do think a lot about how tightly this machine will be coupled to the NIRS system in Lefdal. There are both pros and cons with this, but there will be some connection to the NIRS system one way or another. It's just a question of how tightly coupled it will be. We do know that we will need a low latency network, both for CPU load, but also for GPU load. There's a lot of discussion regarding what is the ratio between a flash storage and a spinning disk storage. We do know that it's a good thing to have different file systems with different characteristics. And we do know that having the latest technology available on the market is not always the best thing to do. If you have the latest and greatest, you also run into the latest problems. To have the ability to expand when there is a need is a good thing to have. And we do know that some sort of cloud burst or elasticity is needed. And the last line there, everyone, everywhere are screaming for more GPU availability. And we are thinking very, very hard about that. So the last thing I would like to mention is that if you have any input for the A2, you might contact me, or you may send your concerns to Jenny Amundsen at Sigma 2. So this is what I have. It was a very broad overview of NRIS hardware, but there you have it.